Packard built 55,523 Merlin engines during the Second World War. More than Rolls-Royce built, more than any other manufacturer on either side of the Atlantic. The tooling was Packard's. The workforce was Packard's. The process knowledge, developed across 4 years of converting Rolls-Royce's metric drawings into American production standards, was Packard's. The engine that powered the Spitfire, the Lancaster, and the P-51 Mustang was built in Detroit on East Grand Boulevard by a company that had started making luxury cars. 13 years after the last Merlin left that plant, the Packard name appeared on a Studebaker. 2 years after that, it disappeared entirely. By the end of this, you'll understand why the company that built more Merlin engines than Rolls-Royce itself ended as a badge on someone else's car, and why the achievement that should have secured Packard's future was the specific thing that left it with nothing to build on. Most people assume Packard failed because it couldn't compete with GM and Ford, that it was simply too small, too slow, too committed to a luxury market that mass production eventually priced it out of. That framing is wrong. Packard didn't lose a market competition. It converted its entire manufacturing capability to the most demanding precision production program in American industrial history, performed it better than anyone else, and emerged from that performance into a commercial landscape where everything it had built toward no longer had a buyer. To understand how that happened, you have to understand what Packard actually was before the war, and what the war required it to become. Packard's precision identity predated the Merlin by 30 years. The Liberty engine program of the First World War had established the template, a 12-cylinder aero engine designed to a common specification and manufactured across multiple American plants, with Packard holding the tolerances tighter than any other participant in the program. That reputation, the company whose dimensions were actually what the drawing said they were, carried forward into the interwar period through the V-12 automotive program, a series of luxury car engines whose machining standards no volume manufacturer attempted to match. The workforce trained to those standards was not interchangeable with the workers GM deployed on production lines designed around acceptable variation. Packard's men built things to the number on the drawing. That distinction was the company's identity and its commercial proposition simultaneously. Ernest Hives arrived at East Grand Boulevard in 1940 without authorization from the British government and offered Packard the complete Rolls-Royce Merlin manufacturing specification. The offer carried a condition that the headline figure of 55,523 engines has always obscured. Before a single production fixture could be built, Packard's tooling engineers had to convert every dimension in the Rolls-Royce drawings from metric to American inch-based standards. This was not a clerical exercise. The Merlin's bearing housings, cylinder bore dimensions, crankshaft journal diameters, and supercharger impeller clearances had been established in millimeters to tolerances that Rolls-Royce's own gauging equipment held. Translating each dimension to inches while preserving the functional relationship between mating components, ensuring that the converted American drawing produced an engine that performed identically to the British original, required engineering judgment on every line of every drawing. The conversion program employed a team of tooling engineers for the better part of a year before the first production fixture was certified. That work is the foundation beneath the 55,523 number, and it has no memorial. The War Production Board suspended civilian automobile production in February 1942. Packard's luxury car line stopped at a moment of genuine market strength. The 1941 Clipper had opened a volume price point that was beginning to recover Packard's commercial position after the Depression had compressed luxury demand. The suspension froze that recovery. The East Grand Boulevard plant converted to Merlin production. The precision workforce expanded and retrained for aero engine tolerances. For 4 years, Packard built nothing a civilian customer could buy. Cadillac, producing vehicles for military officers and government officials throughout the war under limited production. Exemptions, maintained dealer relationships and brand presence that 4 years of complete absence could not easily recover. The prestige segment Packard had shared with Cadillac before the war was a segment Cadillac had occupied alone during it. Packard had the capability. What it did not have was a strategy for converting that capability into a market the war had not already rendered obsolete. James Nance arrived in 1952 with one. The piston aero engine market ceased to exist as a commercial proposition between 1945 and 1950. Jet propulsion had been demonstrated in combat before the war ended. By 1948, every major airline was evaluating jet transport programs. By 1950, it was clear that the next generation of commercial aircraft would not carry piston engines at any power rating. Packard's 55,523 Merlins, its conversion tooling, its process knowledge, and its trained workforce represented world-class capability in a product category that had become obsolete faster than any post-war planning document had assumed. The tooling sat on the East Grand Boulevard floor. The workforce remained. The market for what they could produce had gone. The luxury car restart compounded the problem. Packard's 1946 lineup was built on pre-war platforms. The engineering resources that might have developed a new chassis had spent 4 years on Merlin production rather than automotive development. Component shortages from wartime material allocation affected fit and finish in ways that Packard's quality reputation made more damaging than they would have been for a volume producer. The 1941 Clipper's price point, which had opened a viable volume market before the suspension, was occupied in 1946 by GM and Ford products, whose wartime production continuity had allowed incremental development Packard had not been able to perform. The dealer network that had contracted during the war years had not fully reconstituted. Each problem was individually manageable. Together, they described a company re-entering its market at a structural disadvantage it had not created and could not quickly correct. The Marine Engine Division dissolved in the post-war restructuring without redirecting its capability toward the civilian market beginning to emerge. The 4M-2500 had powered PT boats through sustained combat operations, high power output, saltwater, operational conditions that tested reliability beyond anything a civilian application would require. The engineering knowledge that program represented was transferable. The civilian high-performance marine market was growing through the late 1940s and early 1950s as returning veterans with disposable income discovered recreational boating. Packard closed the division and exited the market before that demand reached a scale that would have justified the decision to stay. The opportunity was foregone quietly, without institutional record of the reasoning. James Nance became Packard's president in 1952. His analysis of the company's position was accurate in its diagnosis and wrong in its prescription. Packard lacked the manufacturing scale to compete with GM and Ford on per-unit cost in the mid-market segments where volume justified the investment in modern tooling, the correct diagnosis. His solution was merger with Studebaker. A combined production volume of approximately 400,000 units annually, sufficient in theory to justify the tooling investment the combined entity needed. The strategic logic depended on a single assumption, that Studebaker's manufacturing cost structure could be rationalized after the merger closed. It could not. Studebaker's South Bend plant operated under labor agreements that produced per-unit manufacturing costs exceeding industry norms by a margin Nance's due diligence had not fully exposed. Those agreements were structural. Rationalizing them required a capital program the merger's transaction costs had consumed. The engineering budget that should have been developing a new Packard platform, a genuinely competitive luxury product that could recover the prestige positioning Cadillac had consolidated, was directed toward integration management that delivered no cost reduction and no product. The 1956 Packard was a Studebaker President platform with Packard body panels and Packard badges. The engineers who had designed Packard's own chassis examined the production car and documented their objections internally. The market examined it and reached the same conclusion by different means. The car that bore the name was not the car the name had meant. The last Packard rolled off a Studebaker line in 1958. The engineers who had designed the V12, converted the Merlin drawings, and built the PT boat engines were already gone. The name outlasted the institution by 2 years. The East Grand Boulevard plant was sold in 1956. The precision fixtures that had held Merlin tolerances to Rolls-Royce specification, bearing housing gauges, cylinder bore standards, crankshaft journal measuring equipment calibrated to dimensions that had been converted from metric by hand, one drawing at a time, in 1940, were evaluated by the new owner for non-aerospace industrial use. Some were repurposed. Most were not transferable to applications that did not require what they had been built to measure. The tooling that had produced 55,523 engines sat in a building that no longer had a precision purpose and was disposed of accordingly. The workforce dispersed into the broader Detroit manufacturing economy. The tooling engineers who had performed the Merlin dimensional conversion, who had translated Rolls-Royce's bearing clearances and impeller tolerances into American production standards without losing the functional relationships the original design depended on, moved into positions at Ford, at GM, at the supplier networks that served both. The knowledge they carried moved with them individually and dissolved institutionally. No aerospace successor program received it. No training curriculum was built from it. The conversion methodology that had made 55,523 engines possible existed in the people who had developed it, and the people had no institution left to work for. The Marine engine team had dispersed earlier when the 4M 2500 division closed. The Liberty engine heritage, the World War I precision standard that Packard had established and maintained through 30 years of automotive and aero engine work, terminated in 1958 without producing a successor capability in any institution that continued operating. The line from the Liberty to the Merlin to the V12 to the PT boat engine was a continuous record of precision manufacturing performed at the highest level the industry had required at each moment it was required. It ended not because the capability failed, but because the institution that held it ran out of commercial continuity before the capability ran out of applications. What remains is specific and physical. A small number of Packard-built Merlins survive in airworthy condition in preserved Spitfires, Lancasters, and Mustangs maintained by restoration groups in Britain, the United States, and Australia. The engines run. The tolerances the conversion engineers held in 1940 are still present in the clearances between components that have been turning for 80 years. The precision is not diminished by the institution's absence. It was built into the parts, and the parts outlasted the company that made them. At air shows, a Packard-built Merlin sounds identical to a Rolls-Royce-built one. There is no acoustic distinction between the engine produced in Derby and the engine produced on East Grand Boulevard. The conversion was exact. The dimensional translation preserved every functional characteristic the original design had established. The achievement is audible and attributable, and completely disconnected from any institution that continues to exist. Packard didn't fail because it couldn't build things. It failed because the things it built best had no commercial future, and the commercial future it pursued consumed the capability that had distinguished it. An institution can perform the most demanding task its industry has ever required and still fail to survive it if the performance consumes the commercial continuity that survival depends on. Packard built more Merlins than Rolls-Royce. It converted the most complex precision drawings in American manufacturing history into tooling that worked. It powered the PT boats and the Mustangs and the Lancasters. The achievement was complete and real and gone. The institution that produced it had spent the war becoming something the peace did not need, and had not spent the war becoming anything the peace did need. That gap is where Packard went. Subscribe if this is your kind of story.